Good morning. If you're watching this video, I'm not in school today, so please do the best you can to pay attention. There's going to be two videos that you're going to need to watch today. This relatively short one, finishing off arithmetic sequences, and then a second one dealing with arithmetic series. So please watch the sequences first and the series second. Okay, where we left off yesterday was looking at what were called arithmetic sequences. Those are going to be sequences in which the difference in consecutive terms is constant. So if you look at the example I have on the screen and you subtract any consecutive terms, as an example, 31 minus 20, 20 minus 9, 9 minus a negative 2, negative 2 minus a negative 11, what we get every single time is 11. So yesterday we said that that's called the common difference. Just write that out. Common difference, all right, is that constant that we get every time we subtract any two consecutive terms. Okay? Now, the type of problem we finished with yesterday was something like this. Given an arithmetic sequence like this, can you tell me what the 214th term is? Can you tell me what the 214th term is? Now, to accomplish that without having to go from the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, all the way up to the 214th, is to use the formula that we talked about yesterday, and I've placed it at the top right-hand corner here. So the formula for an arithmetic sequence is this: a sub n equals a sub 1 plus n minus 1 times d. D is the common difference, just like we got before. A sub 1 is going to be the first term in the sequence, right? And a sub n would then represent any term in the entire sequence, from the first through the 214th to the 2000th to any term you want. Okay? So to find the 214th term, what we do is we start with the very first term, and you can see that the first term up above is negative 13. Then to that we add n minus 1. And what I need you to notice is that n minus 1, what's in the parentheses, is always 1 smaller than the term number. So if we're looking for the 214th power, a number 1 smaller than that would be 213. And then finally we multiply by the common difference, which is 11. All right? So the 214th term can be found by just doing the arithmetic. Negative 13 plus 213 times 11. And when we do the multiplication first and the addition second, if I punch it out, okay, the 214th term then would be 2,330. Okay, just applying the formula that we talked about yesterday. Okay, and that's kind of where we finished. But I'd like to do two more problems that show you how we can do a couple other things with that formula. So here's another example. What I'm going to ask you to do on this one is find the rule or the formula for the arithmetic sequence given that d is equal to 11 and a sub 27 is equal to 263. So with those two bits of information, can you find the rule or the formula for an arithmetic sequence? Okay? So the process goes like this. On the right-hand side of the page, I'm going to create the rule or the formula by starting with our arithmetic sequence formula. A sub n equals a sub 1 plus n minus 1 times d. And our objective is to find two values. We have to figure out what the very first term is, a sub 1, and we have to figure out what the common difference is. If we replace those two variables with numbers, then the only thing we have left is n's, And that's the variable we're supposed to have in any kind of formula or rule for a sequence. Okay? So you read what's given to us. So go back up to the problem, read what's given. The 27th term is 263, and D is 11. So we're actually told one of the two numbers that we're looking for. We're told that D is 11. So we're essentially half done. We found the common difference. What we're missing, however, is the first term. So how are we supposed to be able to find the first term when we're given the 27th term? Okay? And the answer is we'll apply this formula. We'll apply the same dang gone formula. But instead of starting with a sub n, I'm going to start with a sub 27. In other words, we apply the formula to the second piece of information. So I apply it to a sub 27. So what a sub 27 is then going to be equal to is a1, which we do not know, plus n minus 1, which we do know. We know that number because the number in parentheses is always one smaller than the term number we're looking at. So if this is the 27th term, the number in the parentheses is 26. And finally multiplied by D, but hey, they told us that in the problem, D is equal to 11. Okay? And finally, what we do is we remember that we actually know what a sub 27 is. They tell us that in the problem. They tell us that the 27th term is 263, which means there's only one variable left, and that is a sub 1. So we can then solve for a sub 1. We need to multiply 26 times 11. I just need to turn a calculator on here, so give me a second. 26 times 11, so that's 286. And move 286 to the other side by subtraction. So 263 minus 286 gives us our first term being negative 23. All right, so the first term in that sequence has to be negative 23. So that allows us to then replace a sub 1 with negative 23. And so now we've replaced a sub 1 with what it's equal to, D with what it's equal to, and the only variable left again, let me put a little arrow by it there, the only variable left is n, and that's what we're supposed to have. So what I'd like you guys to do is simplify this by distributing the 11 times n, and 11 times negative 1, and then combine the two like terms. Negative 23 and negative 11 is negative 34. Okay? And if you're ever, if you're ever shaky and you just want to see if it's actually going to work, we could then replace n with 27 and see if we actually do get 263 out. Or we could replace n with 1 and see if we get negative 23 out. Okay? All right, so again, trying to find two values, a1, first term, and D. So we're going to finish this video off with one last problem. Exactly the same instructions as the previous one, so I'm not going to waste your time writing all that out. It's simply going to say, find the rule or the formula for the arithmetic sequence given. And this time what we're going to be given is that the 10th term is 148. And the 44th term is 556. Okay? So again, 2 bits of information. And what we're trying to get to is the arithmetic sequence. All right? So therefore, our starting point is a sub n equals a sub 1 plus n minus 1 times d. And I'll use my highlighter again, same color. We're looking for two values, a1, first term, and d, the common difference, right? So you look at the given information. Does it say a1 equals? Nope. Does it say d equals? Nope. So we're going to have to find both of those. We've got to find both the first term and the common difference. All right? And how do we do that? By applying that formula to a sub 10. So we apply this formula to a sub 10, just as we did on the previous problem. So we're essentially replacing a sub n. Let me choose my little arrow. We're going to replace a sub n with a sub 10. Okay? What's it going to be equal to? A1 plus n minus 1 times d. So here we go. What's it going to be equal to? A1, which we do not know, plus n minus 1, which we do know, because we're looking at the 10th term. The number in the parentheses is always 1 smaller, so 9, multiplied by d, which we do not know. And like the previous problem, now I can actually replace a sub 10 with what it's equal to, which is 148. So our equation then becomes 148 equals a1 plus 9d. All right, can you guys solve that? One equation in two variables? Of course not. Has an infinite number of solutions. So you might think, oh, are we stuck? Nope. Because what we do next is the exact same thing with a sub 44. We apply the formula to a sub 44, meaning we replace the a sub n with a sub 44, right? And what's it going to be equal to? Well, let's check it out. A sub 44 is then going to be equal to a1, which we still don't know, plus n minus 1, which is 43. Remember, I was 1 smaller, multiplied by d. And again, we actually know what a sub 44 is. It tells us in the problem, it's given to us in the problem that a sub 44 is 556. So we then get the equation 556 equals a sub 1 plus 43d. Again, all by itself can't solve one equation, two variables. Now, I hope this rings a bell. If I put these two equations together, if I pick up the one to the left and slide it underneath of the one to the right, what we create is two equations in two variables, and I used to use this symbol all the time in front. It's called a brace. We create what's called a system. And way back in chapter 3, we learned how to solve systems. Now, I wish I was in person so we could talk this over better. I'm going to go with a method called elimination. And as I'm doing it, see if it rings a bell. What I'm going to do is I'm going to write down the first equation as is without changing anything. Then I'm going to write down the second equation, but I'm going to multiply the whole thing through by negative 1. As long as I multiply both sides, legal. So 148 times negative 1, a sub 1 times negative 1, and 9d times negative 1. The idea is, now when I add them together, the positive and negative a1 cancel, and what I'm left with is 43 minus 9, 34d on the right, and then on the left, what I'm going to have is 408. I think I'm doing that okay in my noggin, right? And then to solve for d, we just have to divide both sides by 34. And I'm going to need a little calculator help. I think that's a 12, but I'm going to double check myself. Let's see. 408 divided by 34. Yep, turns out to be 12. All right on the nose. So what I can then do, now that I know what d is, I can go up into my equation, and I can replace the replace the d with a 12. Okay? So the only thing I'm left with is a sub 1. So what I got to do is look around for an equation with an a sub 1. And I'm trying to make a little bit of room off to the left here. So, hey, we have an equation with an a sub 1. It's right here. Oh, sorry about that. I thought it was picking my highlighter. There it is. All right, so we have an equation with an a sub 1. So I can solve for it by replacing d with what it's equal to. So I could replace this d with 12. Alrighty. And so when I multiply 9 times 12, I get, what, 108, I believe? And then move the 108 to the other side by subtraction. So a sub 1 is then going to be equal to 40. All right? Just do a little simplifying, and we're going to call it good. Little distributive action, 12 times n. 12 times negative 1. And combine the like terms. So 40 minus 12 is 28. So our rule for the arithmetic sequence then is going to be a sub n equals 12n plus 28. And if you wanted to, you could check by replacing n with either 10 or 44 and make sure you get the terms that we were given at the beginning of the problem. Okay? So that's the end of this first video. I need you to go to the second video, which is dealing with arithmetic series, and work yourself through there. Take some notes. There's an important formula that you'll see that I'll highlight. Make sure you get that down for your note card. Okay? Hope you're having a good day. Talk to you soon.